Good morning. Well, today we're going to look at the graph of the inverse function. Okay, now to find the graph of an inverse function, you reflect the graph of the function in the line y equals x. Now the line y equals x on a coordinate axis is a line where every y number is the same as the x number. So to draw the line y equals x, it would be at a 45-degree angle to the x-axis, and the coordinates would be where every x and y are the same. So the coordinates would be 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and so on. Okay. Also, if you are given coordinates on the original graph, then a technique that you can use is to reverse the x and y coordinates. So if you have 2, 3 on the original graph, then 3, 2 will be a point on the inverse graph. Okay, so here we have an x and y axis. Here we have a little graph drawn there. And the graph of the inverse function will simply be the graph where y equals x, which is at a 45-degree angle to the x and the y axis. Y equals x is the axis of symmetry, and we can see that we have a symmetrical shape going there between the original function and the inverse function. And that's very simply how you draw an inverse graph. You don't even need to know what the original graph is, what type of function it is. You just have to draw an axis of symmetry and draw a symmetrical shape. So it's just symmetry that you're using for that. Okay, so we now have exercise 2F. And remember, if there are any points marked on the original graph, then to mark them on the inverse graph, reverse the coordinates. So if you do have 2, 3 marked in the original, mark 3, 2 in the new graph, the inverse graph. 5, 6 on the original would be 6, 5 on the inverse graph, and so on. Okay, so we're going to do exercise 2F, questions 1 and 2. And good luck and take care, and don't forget to ask your teacher if you need any help.